All right, so I have in my possession the midterms that weren't picked up yesterday. So if you don't have your midterm yet, come down to the breaker after class. I am collecting midterms from folks who want me to look, think we made a mistake. So you can do that between now and Monday. So Monday at the end of lecture is the deadline for that. You have your assignment due tomorrow, and then you want to be coming out, and so on. And Stefan is planning to start running a session on Mondays, not exactly sure of the time yet, where he will go over the previous week's problem set, the solution of the previous week's problem set. So the time will sort of depend on his schedule as well as when we can find a room. But hopefully for some of you, the time will work and you're interested in that. So I'll send that announcement on next final Wednesday. Are there any questions or problems about anything? Yes?
So how would you like us to handle the IO exception in the cache list?
The IO exception?
Yeah.
Okay, he's asking how to handle the IO exception in cache list. How does that happen?
So if scanner throws an IO exception, then it says that you should somehow handle it.
I think you already had it. You already have it.
Yeah, that's not ringing the bell with me. So there's nothing special you need to do, is that what I'm hearing? I already deal with it in the code again. Yes?
For the select method in cache list, it says returns a list that contains each cache seed from cache list so long as C's title contains a title constraint and C's owner equals the owner constraint unless the owner constraint is empty. When you say unless the owner constraint is empty, I'm just kind of confused what that means.
Okay, so he's asking about the constraints on the cache. So what it's saying about the owner constraint is if the user has entered, if the owner constraint is something other than the empty string or null or however you represent no constraint, then you use the owner constraint. But I don't want you to say no constraint has been entered, therefore it's the empty string, therefore all owners fail the constraint because the owner name isn't the empty string. So you ignore the owner constraint unless the user has specified one.
I'm sorry.
Ignore the owner constraint until one is set.
Okay.
Yeah?
On the difficulty scale, it's not anything between like 1 and 1.5.
No.
It's just 1 to 1.5.
Right. The difficulties are just 1, 1.5, 2, 2.5, up to 5. Any other questions?
I think it goes up to 5.
Okay. So last time we were looking at examples of classes, and we're going to look at more examples of classes today before we move on to something else next week. And the first example I want to talk about is a class called MyMap. So the idea is there's a map class, obviously, in the library, but we're not going to use that. We're going to look at what it would take to implement a map. So let's just look at what I have up here on the screen. So there is a main method that uses a MyMap, and that shows you what methods there are. So there's the constructor. The MyMap constructor creates an empty map. I'm probably going to drop the word my here, just to save syllables. So create an empty map. It's a map from strings to strings. So the key is a string, the value is a string. So this maps Utah to 4. I think when I made this example originally, Utah's football team was ranked 4th in some poll. And Ohio State was evidently ranked 1st. So you've got the put method. So the keys, I mean, in this example, the keys are school names. Got the put method, and then I have a size method that'll tell you how many key value pairs there are. And then there's a get method that'll take a key and give you the value back. And there's a remove that you take a key and just take the pair out. Okay? So those are the methods. They're named the same as they are in the real map class. And our job is to implement them. So let me first see if there are any questions about what the methods are. If you're familiar with maps, you should understand how MyMaps work. All right, now down below I have implemented it. I have the class declared and I have it all implemented. But suppose that, and I actually have it coded, so I don't have to type the code during class. But suppose that I didn't have the code or the design or anything, I just had the stubs, basically the class with all the method stubs in it. What would be the next step? Once you've got everything commented, all the Java doc, method stubs are in place, it's time to start implementing. What's the first step in implementing a class once you've done the preliminaries? Yeah?
Write the test cases.
Okay, so he says write the test cases, and that's right. And I have some test cases we can look at here. Right, so I have some, a set of, I don't know how comprehensive they are. That one's fairly involved. But, so I've got some test cases. So what's next? Yeah?
You want to figure out how you want to represent a map?
Okay, he said we got to figure out how we're going to represent a map. So a map object's got to contain some instance variables, and those instance variables contain the information we need to know what's in the map. So who has some ideas? Back to you.
Should do an array list of array lists.
He said use an array list of array lists. So what would the idea be there?
So you could have, actually I don't know.
Okay. All right. Anyway, that's one suggestion. We're not quite sure how it would work, but array list of array lists. Who's got another idea? Oh, he's thinking that over. Yeah.
Maybe you could use like a set to deal with like the keys of the map.
Okay, so he suggests using the built-in set. Okay, and what would the set contain?
It would contain all the keys for your map.
Okay, so you could have a set of keys. So certainly you could keep track of the keys as a set, a hash set or a tree set. But where would the values come in? Somehow there's got to be, you've got to associate value with every key. So think about that, yeah?
Whatever you want your map's values to be, you just have like an integer array or an int array that the set links to. So the value is actually an array. Each value is an array.
Okay, so you're saying each value is an array, but how does the key...
Oh, wait, sorry. I'm thinking, yeah, never mind.
Okay. This is actually, a very important problem in computer science is how do you efficiently represent sets and maps? What's your idea?
Well, if you had two array lists, in one at each index you match index 0 as a key, and then the index 0 of the other one is the corresponding value.
Okay, so what he's suggesting here is what are called parallel arrays. So imagine if we had an array list called keys. And maybe it would contain the keys like Utah and Ohio State. And another array list over here, maybe it's called values. And it contains like 4 and 1. And I drew more space than I need. The array list would just be of length 2. And as other schools are added, like we could put BYU in. And it's, I don't know how they're ranked like 127. Bad year. So parallel arrays. And so how would that work? Someone else tell me how would it work. If you had to look up the ranking, let's say the values or rankings of a school, someone gave you the school like Ohio State, how would you find the value? Yeah?
You would have the program figure out what the placement value in the array of the school, of the first version of the school is, then what the value of the same placement in the second array.
Okay. So you would find out, what he said is you'd find the index at which Utah is stored, in this case 0, right, or Ohio State is 1. And then you take that index and use the same index to look up the values array. So if Ohio State is stored at index 1, its ranking is stored at index 1 in the values array. And conveniently enough, there's an index of method in the ArrayList class. You don't even have to write a loop to find the index. You can just ask it that way. Right? So this is what's involved in designing a representation. You come up with some idea, and it helps to draw it like I did here. And the question you've got to ask is, if this is how I'm keeping track of my information, how will I be able to implement each of the methods? So let's think about that. What would the constructor need to do? So we're going to have, we'll call it keys and values. I may have called it something else in my code. What would the constructor need to do? Yeah?
I would have to make sure that there are no repeats.
Well, okay, so first of all, what the constructor does is return an empty map. Okay? So what array lists, what values of keys and values, what array list should be stored in those two variables to represent an empty map? Well, keys is an array list and values is an array list. Those are our two instance variables. We've got to store array lists into both of those variables. Okay? How long of an array list should we store in each variable?
Like 0.
In other words, how do you represent an empty map? You get to decide.
Null.
We could use null. We could say if there's a null stored in both variables, then it's empty. But that's, it'd be more convenient to use a different strategy. Something that's not a special case. What's another way we could represent an empty map? Yeah?
Just set the array size to 0.
Right, two empty array lists makes sense. So we might decide that, okay, however many pairs there are in the map, that's going to be the length of the array list that we use. So it makes sense, if that's our strategy, to have empty array lists if the map is empty. Okay? So then, what would the put method do? Yeah?
It would add a value to both of the arrays, one being like the key to the key array and then one being the value.
Okay, so what he said was, if we went to put a new thing in, let's assume that this is already full. So if someone wants to add a sixth pair, we would add to the end here some school, like USU, and something over here like 50 or something. That's almost what we need to do for a put. Add to the end of both array lists. What's the catch? Yeah?
You would have to find a way how to increase the size.
Well, in the array lists you can add. Array lists are good. They grow. That's not the problem. Yeah?
You wouldn't want to have multiples, would you, for keys?
You can't have duplicates, you mean?
Yeah.
Yeah. So if someone said, if we were like putting the new value for Utah to be 30, we wouldn't want to add Utah at the end. We first want to check to see if Utah is already in the key. If it is, we go change its value. So you only add a key if it's not already there. Yeah?
It's not obvious to me why you're using parallel lists instead of a tree map.
Instead of what?
Instead of a tree map, because I see
Oh,
keys and
we're not using a tree map because we're trying to implement maps without using the built-in maps. Right? We're pretending there aren't tree maps or hash maps. Same game we did last week with lists. Okay, but he's absolutely right. You wouldn't do this for real because it's already there. Okay. What about how would we do get? Someone says, get me the value of this key. Someone says, get me BYU. Yeah?
But they're all linked by the same index. Just look in keys for that.
Okay.
For whatever value that key holds.
Right, so we would look for BYU's index. We found it. We'd go pull out use the same index over the values array.
Yeah.
If it's not in there, if we don't find BYU, what get is supposed to do is return null. So we return null in that case. What about if someone says the size of the map? The number of key value pairs. Yeah?
You can just take the size of either of the array lists because they should be identical inside.
Right. Just they're going to be the same length, so you return the size of one of them. Just pick one and return it. And what about remove? Someone says remove Utah State.
Find Utah State and then ArrayList.
Yeah, you just find it and you can do it. There's a remove operation. You can remove, add an index in an array list. So it's all pretty straightforward. So let's look at the code. How the heck do you iconify this? So here is the code. I will make it bigger. That's the test. All right, so let's see what I've done. First of all, before we look at the implementation, let's look at the documentation. So here is the Java doc for an array, for a map. It says a MyMap object maps strings to strings. That's kind of a stripped down comment, but the thing I want you to realize is the overall comment needs to describe what sorts of objects are provided. It needs to talk about the abstraction. We don't say a MyMap object contains 2 array lists. You don't talk about how it's implemented. You just talk about it from the point of view of a user. The user doesn't need to know about the array lists. And similarly, the comments that go with the constructor and the methods need to talk about the abstraction. Didn't go down far enough. These comments talk about maps, not about array lists. So, creates an empty MyMap. So, assuming you know what a map is, that tells you something. If the key already maps to something, replaces its mapping with val. Otherwise, adds a mapping from key to val. Remove says, removes the mapping involving key if one exists or does nothing otherwise. Returns the value to which key maps or null. And returns the number of elements in this map. So you don't see any mention of the representation. You should be able to do all this before you even decided how to represent it. And if you change your implementation, you change your private instance variables, it should not affect the comments on the public methods in the constructor. Now, we have to declare 2 array lists. And I did that there. I have keys and values. And these comments, since these variables are private, these comments aren't for anyone that uses the map in their code. It's for anyone that needs to understand the implementation. So they're different. They actually talk about what's going on inside. So this first comment says, keys and values are parallel arrays. So that's, I'm assuming that the reader knows what parallel arrays are. The keys list contains the key of this MyMap without duplicates. And the values list is the same length as keys. If a key is stored at key sub I, the corresponding value is stored at value sub I. So there's 2 pieces of information in the, there needs to be 2 pieces of information in the comments that you give for these instance variables. Number 1 is, you need to note any restrictions on these, on the values of the variables. Can any 2 array lists be stored in keys and values? Are there some combinations of array lists that are never going to occur? What do you think? Yeah?
Array lists of booleans.
Well,
Array lists of booleans.
you don't need to, okay, array list of booleans will never be stored in these variables. You don't need to say that in the comment because it's, it says right there it's array list of strings. So can you think of 2 array lists of strings that could not, one that store, that you'd never see them in combination if you cut an object open. There are lots of examples. What would be an impossible situation? Yeah?
I don't know if it's possible, but one string array list with a longer length than the other.
Right. You're not going to find 2 array lists, keys is not going to be longer than values, and vice versa. So I noted that in the documentation. I said the values list is the same length as keys. Right? So that if there's any restriction beyond what's expressed by the types, you need to note that in the comments. And then there needs to be enough information in these comments so that if someone says, okay, what array list would be used to represent a particular, they got some map in mind, they want to know how it would be represented. Or they have a representation, they want to figure out what map it represents. It should be possible for someone to read that and start drawing pictures like I was drawing. Right? That's the level of detail I want to see when you document instance variables. It's important that you document them. People like to skip doing that for some reason, but it's crucial. All right, let's look at the implementation now. Right here is the constructor. And like we agreed, we decided we would represent keys and values as empty array lists. So an empty map, if you cut it open, you're going to find empty array lists in it. Okay? Here's the put method. And let's see what we're doing here. We're going in, finding out the index at which key occurs. If the index is greater than or equal to 0, that means that the key really existed. We just go to the values array and we change it to contain val. So this case right here means the key existed. Otherwise, index will return a negative number otherwise, and so otherwise we just add to the end of keys and add to the end of values. So either way, one way or the other, the thing changes. Either gets longer or we've changed the value. Very straightforward code. I think you'll find when you first start writing code for these assignments, most of the methods are pretty simple. It's just a matter of choosing a representation that all the methods agree on. Yeah?
I was wondering, ArrayList also has master life index.
Yeah, it does.
Okay.
Yeah, it's a convenient one to know about as the index of method. Any other questions so far about the constructor and the put method? So every time you put a key that wasn't in there to begin with, the array list grows. It's one longer. Both array lists get longer. That's always going to be true with parallel arrays. Yeah?
And just because this already checks for duplicates too then, right?
The way it checks for duplicates is, yeah. So when if we get back a non-negative index, we know that the key already existed. And so we just go change the value that goes with the key. If we get back a negative index, a negative number, we know the key didn't exist and we add both the key and the value at the end. Any other questions? Okay, here's remove. So again, we're asked to remove a key. We find out its index. And if we get back a non-negative number, that means the key was in the keys array. And so we remove what was at that index in the keys array and remove what was at that index in the values array. And we're done. If the key wasn't there, we just ignore the request. Nothing to remove. So this is how the list gets short. The map gets short. Here's the get method. Again, we're making use of index of. We find out where it's stored. If it's not actually there, if the index is negative, we return null. That's just what it says to do. Otherwise, we go get the value at the specified index and return it. So there's not a single loop in this. Where's the looping happening?
When you call it class.
Yeah, it's when I call index of. Index of contains a loop. And there's size. We just return the size of the keys array. Or we could have returned the size of the values array. So one thing we might, we said in the documentation that keys and values need to be the same length. Who could convince me they are the same length? How could you look at this code and argue that they're always the same length? Yeah?
Whenever you're adding or removing to them, you're adding or removing to both.
Okay. So what he said was, whenever you're adding or removing, you're doing it to both. So in size, we're not changing the length of either array. In get, we're not changing the length. In remove, it can become shorter, but they both become shorter by 1. We do the remove in pairs. Up here in add, we're adding to both, and they start out the same. So they start out the same, and the only way they're changed in tandem. Furthermore, the variables are private, so there can be no outside code that's coming in and directly modifying the instance variables without going through these methods. That's another reason we keep instance variables private, because we're depending on the arrays being the same length. And if we made these instance variables public, some code might muck around with it, and suddenly that assumption is no longer valid, and our own code starts to not work. Yeah?
So I forget if it's like tree sets or tree maps, but isn't there, like, when you do the add and the key is already contained in the set, wouldn't it return a value of false? Or is that?
Add?
Yeah, it wasn't.
Or put?
Yeah, maybe it's.
Yeah, well, our put method is void, so there's nothing to return.
So would you be able to add that in though, just by?
Sure. What we could do is you could add a Boolean and say if the key was already there, return true, say, and if you had to add the key, return false, and we would just add a return to here, return true after we did that, and return false right down here. Be easy enough. Yeah.
So this may be a dumb question, but what happens if you make the member methods private?
Okay, he's asking what would happen if we may say add, or rather put, remove private. What effect would that have if we made them private? Yeah?
You would be able to use it in another class.
Right, some other class that's using your map would not be able to call it put or remove. It'd only be usable inside the class. So you may find it useful in your assignment. You may decide you would like a helper method in your class. And that's fine. You just probably ought to make it private. Yeah? Yeah?
When you're using a helper method, like making you do it private, what's the best way to test it since you can't call
Okay,
it?
that question, how do you test a private method, was asked on the forum, and it's an interesting question. Because the test class, since it's private, the test class won't be able to access the method. And my answer has always been, you just, the private method only matters, no one's going to use it directly. It's there to be used by the public methods. So we test it essentially indirectly by testing the public methods. That's not an entirely satisfactory answer. There are cases where you'd like to be able to directly test private methods. I pointed, there's an interest, you can find all kinds of interesting debates about this, philosophical debates about how you ought to test private methods. My best answer is if you really want to test it, just make it public and test it. Then you make it private again or something. That's sort of a practical answer. Yeah?
So, indirect method to test, do you mean like use reflection?
Oh, yeah, he's saying about using reflection. That's an advanced technique I'm not suggesting. What I just mean is, say there's a helper method that's used by both put and remove. Well, you just test put and remove, and if they're correct, that's all you care about. You're in the process, you're making use of that private method, but you're not testing it directly. Okay, that's one way of representing an array, a map. I want to look at it a completely different way. Who can think of another way to do it? Maybe just using one array list. Yeah.
An array list of array lists. Set.
Well, an array list of array lists, I'm still, okay, I think I know what we're going after now. So, back to the drawing board here. It's still there. So an array list of array lists, maybe what we do is we create an array list, and then each entry contains an array list of length 2.
Could you potentially do dot split to that and be an array list that contains arrays?
Well, it could be an array list of arrays, I suppose, but that's not the point I'm trying to make. So how would you use this to represent the same thing over on the left, the same map as is on the left? How does this work? Every entry in this array list right here, you can't see that. Every entry in this array list right there refers to an array list of length 2. What's the point? Yeah?
Well, all the sub-array lists, you could say, for every index 0 that's a key, every index 1 that's a value, but so
So this would have to be an array list of strings, and then we would store Utah there and 4 there. And we would store Ohio State here and 1 there. And we would store BYU there and 127 there. And so on. Right? That's another way we could do it. Yeah?
Can you make 2D array lists?
Well, this essentially is a 2D array list. It's an array list that contains array lists. What is, yeah?
If we know that we're only gonna need 2 spaces, wouldn't it just be better to use an array? Part of the-
Okay, so we say maybe instead of, since we're only going to use 2, we could just use an array of strings instead of an array list, which is more space efficient. Okay? There's a, you know, what would it take to do the get method now? If that was our representation right there, how would you find BYU? Yeah?
You'd have to search through each one, and you'd have to search through each of the first array's values for that array list, then look at the first value in that second array list.
Okay.
For example, going into the one that contains U4, looking at the first, assuming you have that standard in each of them.
Okay. So he's saying we would look here, we would index into this thing here, that would obtain, then we would obtain this thing right here. And we look at its index 0, the index of that array, index 0 of that array, and we would see if it's BYU. If it is, we would return this 4 as our answer. So eventually we would come down here, we would find this guy, we would find BYU there, we would return 127. So yeah, this would work, but someone has already mentioned a drawback to this approach. And that is, what would happen if the keys and values weren't the same type? Suppose the keys were strings, but the values were actually integers instead of strings. What would go wrong with this? Yeah?
You can't have different types in array lists.
Right. So that these little array lists of link 2 suddenly going to have a string stored at index 0 and an int at index 1. And that won't work with array lists. So it's not a general solution. So the solution I'm going to propose is essentially, we'll use that same picture. But now, instead of these guys right here being array lists of link 2, they're going to be pair objects. So these things are going to be pairs. In fact, they're going to be pairs where one contain a key and a value. Now, where are these pair objects going to come from? There is, alas, no pair class in the Java library. If only we had a pair class, we could implement MyMaps with them.
Why would we just implement it in the class?
What's that?
Why would we just implement it in the class?
Right. So just as you can have helper methods, you can have helper classes. So here, let me show you what I mean. This is the next MyMap. Actually, I'm getting ahead of myself. Here is my pair class. So I just created a pair class. It provides key value pairs. Internally, privately, it has a key and a value stored in it. It has a constructor that takes a key and a value and stores them in the instance variables. It has a method to get the key out, a method to get the value out, and a method to set the value. And that's that. Very simple class. Simple classes, the simplest classes tend to have a constructor and then what are called getters and setters, where the getters return the values of instance variables and the setters change the values. So let's just look at this. See, it's about as simple as a class gets, but it makes implementing the map a little bit easier, because we don't have to strain and use array list of link 2 or arrays of link 2. We just use one of these objects for each team. So let's look at the code. Like, we got the instance variables up here. The getter just returns the value, the get key returns the value of the key instance variable. Get value returns the value of the value instance variable. Set value changes that value. The constructor sets their values. I know about half of you have a question you want to ask right now, but you're not asking it. Yeah?
So if we're making this new class where we don't have to have them both be strings, why do we still have them both be strings? Like, why can't we just store value as an int?
Well, we could. So he asked, after all I said, I'm still storing by key and my value of those strings. That's just because that's what MyMap says. But you should see that if we wanted to have key be a string and value be an int, we would just change that to an int.
Right.
Change that to an int. Change these to ints. So it'd be the same sort of thing. Yeah?
If we wanted to make a pair class for a different context that could have variable types involved, would this be a situation where it's appropriate to have multiple constructors for the same object taken in?
Well, what flexibility are you asking for? To create different kinds of pairs with different types?
Yeah, if we were in just a different context where we didn't necessarily know what types we were going to need.
Okay, so it's not, so we're not talking about multiple constructors in that case. We're talking about generic types. So an array list is an example of a generic type. You can say array list of string, array list of integer, array list of whatever. And the thing that goes in the angle brackets is a type parameter. We could define pairs that way. We could say, we could have it so you create a pair, you would say pair and then angle bracket string integer. And now you have a pair that maps strings, or a pair that contains a string and integer. You could say pair, random, comma, double. But I don't want to get into generics. That's a topic in 2420 though. But that's the thing. Generic types is what to look at if you want to know what I just babbled about. But you're still not asking the question that I think most of you wish someone else would ask. Look at the constructor. What's weird about the constructor? Maybe it's not weird. Maybe I'm just off the wall. Yeah?
There's no default constructor?
Well, there's no default constructor. That's true. So you can't create, but would you want a constructor with no parameters? What pair would it create? It could create a pair where both the key and the value are empty strings, I suppose. But basically, I didn't put a default constructor, a zero argument constructor in this thing because I didn't need one. This thing is designed to make it easy to implement MyMaps, and this is exactly what I need. If I can write with this here. Well, what's up with this right here? Why do I have this right there? This dot key equals key. Surely that looks strange to a number of you. This dot value equals value. Yeah?
Well, it assumes that you need the parameter key if you don't.
Okay. So what I'm doing is I'm taking the value of key, the parameter that comes in, and that's what this refers to. Key refers to that. And I'm storing it. What if I just written this?
It would recognize it as the parameter.
It would take the value of the parameter and store it back in the parameter. Okay? So what some people would do is this. To not use the same name. Okay? And that's clearly, up here's the instance variable. That's taking the value of k and storing it in the instance variable key, which is what we want to do. Well, sometimes I'm hard-pressed to think of one good name for something, let alone two good names. And key is what I want to call it. So I do it that way. And so this dot key makes it clear, I mean the instance variable. This is a reference to the object being constructed. Key is the instance variable it contains. This key refers to that instance variable, to that parameter right there. So that's why I put this there. Because I'm using a parameter that has the same name as an instance variable. And so I'm disambiguating. I ended up doing the same thing down here at set value. Because the incoming parameter is called value. This means, okay, you're invoking set value on an object. That object, which is this, will contain a variable called value, an instance variable called value. Change its value to be the same as this thing here. So sometimes, even though this, sometimes this is implicit, sometimes you want to make it explicit just to avoid ambiguity. Let me show you one other fine point about this. What do you notice different about this line right here? How's that different from any class I've ever shown you?
There's no public.
It's what?
There's no public.
Right, it says neither public nor private. So if you don't say how it's protected, its visibility, The default protection level is it can be used inside its package, but not outside its package. So if we go back to here, pair shows up in the map2 package. So you can use pairs in the MyMap class and the MyMap test class, but not outside. And that may or may not be a good decision. Maybe you decide that the pair class is really valuable, so you make it public. I just wanted to show you an example of this. So let's look at the implementation of MyMap now. Okay, here's our representation. Now there's just one variable called pairs. It's a private array list of pair objects. And it says for each item in the MyMap there is a pair in pairs, and that shouldn't be capitalized, that contains the item's key and value. No key can occur more than once in pairs. Okay, that's just summarizing the idea behind that picture we drew. And then the rest of the code, let's see. We create an empty array list to represent an empty map. Good. Put, now we have to write our own loop. So put just, I use KVP for key value pair. It just loops through every pair object in our array list. And if it finds one whose key equals the key we're looking up, we set the value part of that key value pair to val and return. If we don't find it, we add a new pair to the end of the list. So we loop looking for a pair that contains the right key. If we find it, we change its value. If the loop ends, we add to the end of the array list. The rest of the methods are going to look very similar to this, so I'll wait here and answer any questions you might have. Yeah?
So I have a question about the helper methods with testing them. So with your pair class not making it public or private, only usable in its package, would it be beneficial to just put all your helper methods in a class like that so you could test them but they couldn't be used outside your program? Okay,
so he's asking about putting helper methods in a separate class and protecting with the default protection, package protection. That works if your helper methods don't need access to the private instance variables of the class they're being used in. And that's often the case, that the methods really do need to be in the original class so they can access instance variables. Right? Well, what about remove? It's the same type of loop. We loop through all the pairs. If we find one whose key is equal to the parameter key, we remove it in return. So we remove the thing of that index and we're done. So in all this, we're going down through we're just going down through this list right here, looking at the key. Looking at the key here, looking at the key here. And when we find one that matches, we change the value that's right there, and we're done. Get, same loop. Yeah?
I just want to clarify, when you made the array list of pairs, you created pairs, right? Like that's something that
I created a pair, yeah.
Okay.
Right. That's the pair class we were staring at right here.
Oh, okay.
Yeah.
Okay,
Okay, so there's get. It just loops through. When it finds a key, it returns the corresponding value. If it doesn't find it, it returns null. And there's size. It just returns the size of the array list. So as to which of these implementations is better, yeah, you know, no biggie. They're both bad. And the reason they're bad is when the map gets huge, these operations get very slow because in general you have to go through the entire array list. In 2420 you'll study two techniques to make this sort of thing faster. One is called a binary search tree. That's what's used in the tree map in Java. The other is called a hash table. Hash table, that's why you have hash maps in Java. They use different technologies. Both of them are way faster than what I've done here. Okay. So I got one more example to do, but I'm happy to answer questions about this before we change topics. So ask away if you've got questions. Yeah?
I just want to make sure, that's a for each loop, right?
This here?
Yeah.
Yeah, that's a for each loop. Just every time, so we got a collection, in this case an array list of pairs. Each time through the loop, how did this become capital? Ugh. That is really hard.
I was going to ask you that during break.
It was even hard to look at. Just had a migraine. Okay. Every time through the loop, the pair variable takes on a new value from the list, from the array list. Now, why didn't I use a for each loop up here? Why did I actually generate the indexes and then index into the thing? Why not just use this for each loop, which is a lot simpler? There's a reason. It wasn't just... I use a for each loop when I can. If I can't, I don't. So why couldn't I use a for each loop up there and remove? Yeah?
Just make sure that each value corresponds to the other.
No, it wasn't for that reason. Yeah?
You don't have to search through the list, you're just removing.
Well, I am searching through the list. I'm searching through the list to find something to remove. Yeah?
So you don't have a boundary exception?
That doesn't have anything to do with the boundary exceptions. Yeah?
Each element has a specific index.
Well, it's true that each element has a specific index, but why is that important here? Yeah?
And isn't it in a for each loop you return a pair object where if we go to remove, we don't want to return any pair object, we want to do something just to that object?
Okay, that's getting closer. How do you actually remove something from an array list? What do you have to provide as a parameter? The index. So it's right here. We needed to have the indexes available so that we found what we're looking for. We could return the thing, we could remove the thing at that index. Sometimes you've got to generate the indexes because you need an index. Sometimes, like down here, you don't. We didn't need an index in here. We just needed to get the pairs one after the other. So the way I program is I use a for each loop if I can. And sometimes I can't because I actually need the index for some reason. And then I use a different technique. But for each loops, once you get used to them, are a lot simpler to look at, read and understand. Yeah?
So if you did do a for each loop, could you just do a counter variable and you could use that as an index?
Okay, so he's suggesting I could have used up here I could use a for each loop and then have another variable I and just increment it every time the loop went around. And then I would have my index. Yeah? I could have done that. Okay. Let's take a quick break and Jack, why don't you come down and give back midterms to people? So if you need to get your midterm, come see Jack.
I'm going to think everybody's coming to see me. He actually just wants to go.
Okay, so I promised we'd do something different. So we're going to look at a new class. Let me do some sketching for you. Save that. Okay, so I would like to be able to do arithmetic with rational numbers. I would like to write a program that's able to use rational numbers, the same way I can write one right now that uses integers or floating point numbers. So what does that mean to be able to do arithmetic using rational numbers? Give me an example. Adding two rational numbers. What is a rational number?
2 plus 1/2.
Okay. So here's an example. It would be like 2 plus 1/2, or 3/4 times 1/6, or 1/8 minus 72/5. All right? So it's just arithmetic with fractions. Okay? Now, there is no rational number class in Java. So we're going to create a class. We'll call it rat. And each rat object will represent a fraction. And the methods I want to have, I want to be able to, first of all, I want to be able to create, this is what I want. I want to be able to have a constructor that takes no parameters. And that will create the rational number 0. Got to have it create some rational number. We'll call that 0. If we do this, if we say create new rat and we pass in an integer, like -2, that'll create the rational number -2. Every integer is also a rational number. Or if we do something like this, new rat 1, 5, that'll be 1/5. So we've got 3 ways to create rational numbers. We can create 0, we can create one that's actually an integer, in other words the denominator is 1, or we can create a fraction by giving the numerator the denominator. Now, besides that, I want some methods. If I have a rational number R1, I want to be able to add it to a different rational number R2. Say and store that in a third variable. So unfortunately, I'd like to be able to write it like this, R1 plus R2. But Java doesn't let you redefine the operating systems. There are languages that do, and it's kind of neat, but Java isn't one of them. So I'll have to, instead of saying R1 plus R2, I'll have to say R1.add R2. I'm also going to have a method called .sub, .mul, and .div for divide. I also want to have a .equals method to tell me if 2 rational numbers are equal, and then I want a method toString, which takes a rational number and turns it to a string. And I think I have a method called toDouble as well. That would take a rational number like 1/3 and turn it into a double, 0.33333. So approximate as close as possible to the actual fraction. That's my goal, is to have all those methods. And I've got it. I've got the class all spec'd out. I've got test cases. I've got all the stubs written. So we can move directly to deciding how to represent rational numbers. Inside each rat object, what do I need to have? What instance variables do I need? What do I have to keep track of to have a rational number?
Numerator and denominator.
Okay, so he said, maybe I want to have a numerator and a denominator. Maybe that's our representation. Does that make sense? Can you even think of a better way to represent? I can't. You need a numerator and a denominator. But there's some fine points you need to think of before we start. So one good thing to do is just to think up some rational numbers and decide how they'd be represented. I need some space here. I'm trying to figure out. I'm new to this here. Make some space up here. Okay. How would we represent, say, 1/5? What would the numerator be, and what would the denominator be? Very good. 1 and 5. Okay. Now, what about 2/4?
Do we want it simplified?
Okay, so we have to decide. Do we store the 2 and the 4, or do we first reduce it to lowest terms and store 1 and a 2? Same fraction, same rational number. So what are the pros and cons? Should we keep things in lowest terms? Yeah?
If we reduce it to lowest terms, that'll be best for the math operations and make it easiest to convert to double.
Okay. So he's saying it'll make some of the math operations easier. I'll tell you why it's good for the math operations. We are vulnerable. Integers can only get so big. So the numerator and denominator can only get so big before they overflow in Java, right? We only got 32 bits. So if we keep things in lowest terms, it keeps things smaller, so it takes longer to run out of bits. There's another reason it's a good idea. What other operation does it make simpler if you know that you're in lowest terms? Yeah? Dot equals. Suddenly equals becomes really easy. You just say are the numerator and denominator the same. So let's make our goal to be to have a unique representation. So part of that for every rational number. So first rule is we're going to use lowest terms. Now what's something else that could come up? What's another example I could give that might confound us? We have to think a little bit. Yeah?
What if it was decimal representation of a rational number?
Well, we're not going to use decimal places, just integers. Yeah?
0 denominator.
Okay, what about if someone passes a 0 as a parameter, as a second parameter to this thing here? It says create the rational number 1 over 0. What should we do? What do you think my specification says to do?
Must be non-zero.
Someone take a position out loud. Yeah?
Throw an illegal argument exception?
That's exactly right. Yeah, you just can't have a 0 denominator, so we're going to throw a legal argument exception. So you don't have to worry about the denominator being 0. It'll never be 0. What about 0? How would we represent the number 0? So this is going to be 1 and 2. How should we represent, what's it? So we're putting things in lowest terms. What's that mean for 0? You know, lowest terms are going to be 0 over 9. What about this one here? No, I didn't mean to do that. I didn't mean to do that either. Okay.
Protractor.
Ignore that 1 right there. Suppose the numerator is 1 and the denominator is -2. How should we store that? Should we store it as 1 over -2? Or as -1 over 2? Or does it matter?
It doesn't really matter, but it's probably nicer to do -1 over 2, because that's what's
Okay. We want to be consistent.
You put none, by the way.
Hmm?
You put none in dim.
That's true. Okay, we want to use the same representation for, that dot is bugging me now. We want to use the same representation for 1 over -2 as we do for -1 over 2. So we'll just decide that if the number is positive, both the numerator and the denominator will be positive. If the rational number is negative, we'll put the negative number in the numerator. So we'll actually represent 1 over -2 as -1 over 2. Well, yes. Numerator will be -1, and the denominator will be 2. So that's our idea. We're going to make sure that it's always in that form. So you would never have a rational number object and cut it open and find a numerator that's 2 and a denominator that's -2. What would you find instead for that number? Numerator of -1 and denominator of 1. Both of those fractions, if you will, stand for -1. But we're going to require a unique form. Then equals becomes trivial. How do we put something in lowest terms? Suppose we have 3/9. How do we know that its lowest terms is 1/3? Yeah?
You could use mod maybe.
He said we could use mod. There's actually like a 2,500-year-old algorithm we could use to put things in lowest terms. Euclid. What's that?
Oh, I said, never mind.
Okay. Euclid, Greek mathematician. Yeah?
Can we use like mass GCD?
Right, greatest common divisor. So to put something in lowest terms, you divide both the numerator and the denominator by the GCD, the greatest common divisor of the numerator and denominator. So if you've got 3/9, what's the GCD of 3 and 9? What's the largest integer that divides evenly into both? 3. So you divide the 3 by 3 and the 9 by 3, and you get 1 and 3, 1/3. So it's easy to put things in lowest terms. Yes?
I think there's one more, -1 over -2.
Okay, so if we had -1 over -2, what should the numerator and the denominator be? Right, 1 and 2. The only thing that can be negative is the numerator. That's our rule. Now, we didn't have to be this way. We represent them however, and then make the equals method more complicated. But, so my point is, when you're implementing a class like this, you're the designer. You can decide how you're going to represent things, but you've got to have a solid understanding. You've got to be able, someone should be able to walk up to you and say, okay, 3 ninths. How would that be represented in your class? You should be able to answer. Okay? Or if someone points at a value for numerator and denominator, they can say, what fraction is that? You should be able to answer. If you can't answer questions like that, you can't start coding. You've got to know what your representation means. You've got to think about it long and hard. All right, let's look and see how this plays out in code now. So I got rat.java here we're going to look at. So this is interesting. I didn't remember I did this. I have got the rational, I've got a constructor that creates the rational number 0, like I told you. I've got one that creates the rational number n. I just noticed I'm using longs. So a long is just like an int, except it's longer. Why do you suppose I used long for this instead of int, back when I made the example of it? The answer was, in case I want a giant fraction. This lets me create larger numerators and denominators before I run out of space. So with longs, you got 64 bits to play with. So it can become much larger before they go haywire. So long's no big deal. It's just twice as long as an int. So I've got a constructor that will create the rational number n. I've got one that will create the rational number n over d. It throws an illegal argument exception if d is 0. Here I have an add method. And the thing you realize, if you invoke the add method, remember, it's going to look like this. If x is a rational number and y is a rational number, it's going to be x.add y. Okay? It's going to look kind of screwy. It's not symmetrical between x and y. They're treated differently. Same thing for sub, same thing for mul, something for div. Oh, here's one I didn't mention. I've compared to. I want to know which is bigger. 2 string, 2 double, and here's GCD. I've already implemented it. So we've got the helper method implemented. Okay, so that's what we're shooting for. So what do we need to do first? Yeah.
Initialize the numerator and the denominator.
Well, before we can work on the constructor, what do we need to do?
Create your instance or test.
Write the fields.
Yeah, we've got to declare the instance variables. So we'll do private long numerator.
You choose n and d.
He said use n and d.
Oh, no.
We could. I'll do this way. And we need to add comments explaining our strategy. Okay? I've just spent 10 minutes explaining the strategy. I'll add this in later, so you don't have to watch me mistype a lot of stuff. But what this would say is our strategy, that numerator and denominator together represent the fraction num over denom, over den, whatever. Den has to be positive. Num has to be, it can be anything. And the GCD has to be 1. The GCD of the absolute values have to be 1. So you'd want all that information, the restrictions, and what rational number the combination of instance variables stand for. That needs to be in those comments. I'll have to add them later. Okay, so given that we understand how this works, the job of this guy is to create the rational number 0. So what combination of numerator and denominator did we decide we would use to represent 0? 0 for the numerator, 1 for the denominator. And I just did what I said I wouldn't do. No, that's right. Okay. So that'll create the rational number 0. Now, if we hadn't just had this long discussion, and decided on a representation strategy, we wouldn't know what to put for numerator and denominator. And I've seen students do this all the time. They'll declare some instance variables, don't give it much of a thought, and come to me and say, what values do I assign to my instance variables in the constructor? And I'll say, what's your representation strategy? What's your plan? And a lot of times they don't know. They haven't thought about it. They just know they're supposed to declare some instance variables. You should spend, if you're doing this right, you'll spend more time designing the representation than writing the code. If you don't think about the representation long and hard before you start coding, you're going to waste a lot of time. So you've got to have this solidly in mind, what the plan is. Yes, Deb?
Out in the workforce, they have people who do that job. That's their only job.
Okay.
Or they're analysts, and they just do all the designing, and then they pass it on to the programmer.
Yeah. So you can get people whose job is just to do this. Okay. We want to create the rational number n. Okay. How do we decide to represent a rational number that's a whole integer? Like 6. What should the numerator be for 6, and what should the denominator be? Yeah? 6 and 1. That's the lowest terms. We want to do 12 and 2. Okay? Now, I shouldn't say 6. What should I say? N. Okay? Down here. Well, first of all, if d is 0, throw new illegal argument exception. Not a lot of those. It's not even there, is it? Okay. What if d is not 0? How are we going to represent n over d? Do I say numerator equals n and denominator equals d? Okay. I'm seeing some people nodding their head, but that would be wrong. I do not say numerator equals n, denominator equals d. Why not? Yeah?
Because what if you had like negative numbers?
Right. What if d is -1 and n is 5? What should I be storing? What was our plan? N, the numerator needs to be -5, and the denominator needs to be 1. If n is -2 and d is -3, I need to store 2 and 3. If n is 10 and d is 20, I need to store 1 and 2. You can't abandon the plan halfway through. You've got to follow through. It's the responsibility of each of these constructors and the methods to stick with the plan. So we've got some work to do. Okay? We've got to manipulate numerator and denominator so that they're correct. Yeah?
Can you just do if d is less than 0, numerator is -n?
Okay, so if d is less than 0, we're going to say d equals -d. And n equals -n. So what have we just done? So I just flip the signs. If the numerator is negative, I don't allow that. So I flip the sign on the denominator. I need to flip the sign on the numerator too to keep the number the same. So if what I get is -2 over -3, both get changed to 2 and 3. Yeah?
I think that's a really cool solution actually, because it takes care of multiple issues we need to address.
Right. So what she's pointing out here is this deals with the case where the numerator is positive and the denominator is negative. It also takes care of the case where they're both negative. It flips them appropriately. So after this statement, you're guaranteed that the denominator will be positive and the numerator will be whatever it needs to be. Now what do we need to do? So this deals with signs. Right, now we got to deal with the GCD. So this GCD doesn't want negative numbers. So what we have to do is, so now we'll deal with lowest terms.
Did you just write my name?
Hmm? All right. Let's compute the GCD. Not long. So we need to take the GCD of the absolute value of n in D. Because my method down there doesn't want negative numbers. So we take the absolute value, we take the GCD of the absolute value of the numerator and the denominator. Why don't we have to take the absolute value of the denominator?
We already handled it above in the code.
Yeah, we know it's positive. We already made sure it's positive. And then what do we do with that? Why do we compute the GCD? Yeah?
You put nu equals n divided by g, and same with the denominator.
Okay. So we could say nu equals n divided by g, and denominator equals d divided by g. And that gets the right values. That sticks to our plan. We had to work pretty hard. So we're working hard in the constructor to get everything just so that the other methods don't have to worry about this stuff. This constructor keeps things the right way. Cool. Any questions about these constructors before we look at a method or two? Got 5 minutes left, so I'll be finishing this next time, but yeah?
Why did you name all your methods rat?
I didn't name my methods rat. I named my constructors rat. Because they're all constructors of the rat class. And constructors, that's how you make a constructor. That's the same name as the class. Now, my methods return rats. So like right down here, add takes in a rat and returns a rat. So how can you take in one rat? What are you adding it to? What are we adding to R right here? Give me a one-word answer. This. The 8-word answer is we're adding R to the object in which the method was invoked. So if you do x.add of y, you're adding y to the object in which the method was invoked, which is x. But as we all know, the object that in which the method was invoked is this. So we're adding, this method adds this and r. It says right there, returns a sum of this and r. Well, I'm going to skip these. And let's just do toString. So here's the thing. 3/4 needs to come out as 3 divided by 4. 6/8 had better be in lowest terms. I don't want to see 2 divided by 1 when I convert to a string. I want to see just 2. I don't want to see 0 divided by 8. I just want to see 0. And any negative number had better come before the numerator, not in the denominator. So what's the simplest code we could write? Given that we're careful to construct everything with lowest terms and the negative numbers put in the right place and so forth, what do we do here? Does this work? Does it work to just say numerator plus slash plus denominator? Will that print out will that return the right string every time? No. And when does it fail?
Anything where the denominator is 1 or the numerator is 0.
Okay, so if the denominator, well, actually, we're going to cover those with the same case. If the numerator is 0, the denominator will be 1. So if the denominator is 1, we just want to print out the numerator. So we say if the denominator is equal to 1, I say print out, but we're not really printing. We return the numerator, else we return the denominator. Now why is Java complaining?
Because the numerator is not a...
Because that's an integer, long. We've got to convert it to a string, and what's my favorite trick for turning something into a string? I just append it to the empty string. I don't know. Maybe other people don't like that, but that works. Is this going to work in all cases? Will the negative sign ever show up in the denominator? Right. It can't, because where do rational numbers come from? They're created by the constructor. Rats are created by a constructor. The constructor is not going to create one with a negative number in the denominator. So we don't have to worry about it. If it's negative, it'll be in the numerator and it'll show up like it's supposed to show up. Yeah?
So why wouldn't we put this if else in the constructor just to get it out of the way?
This if else, because in the constructor we're not producing a string, right? So we don't want to put in string form except when we've got to convert it, because we need the numbers to do the arithmetic. When we actually do add, sub, mul, div, we need those integer values so we can do arithmetic. All right, there is like 1 minute left, and I at least want to do some arithmetic expression. The easiest one is mul. So I'm going to show you how to do mul, and we'll talk about it next time. I got to create a new rat. I got to return a new rat. What's the numerator going to be? So if you multiply a over b times c over d, what's the numerator in the product? So a over b times c over d is going to be a times c. So how do I get those two values here? What are the two numerators? Right, the numerator of this and the numerator of r. And the denominator is this dot denominator and r dot denominator. And voila. That works for multiplication. We're multiplying this and r, so we take this dot numerator and r dot numerator and multiply them, and that's the numerator of the answer. Same thing, the denominator. The constructor takes care of lowest terms, signs, whatever. And we're golden. Okay? You gotta have that, you gotta have your representation idea firmly in mind, or you just get confused with it. So we'll stop here and finish this next time before we go on to something else.